Hello, everybody. In this video, I'm going to go through our lesson video on 7.2, dilations and scale factor. So first, I want to remind us of the definition of scale factor, because we talked about this in our last lesson video and in our last, just lesson in general, but it's an important definition. So a scale factor is a ratio comparing the side of an image, meaning the dilated side, to the original. And I should say dilated side length to the original side length. And oftentimes the letter that we see used to represent scale factor, this is K. So K, then it's a ratio between a length of a side in our image, meaning the new dilated shape. So that will be our numerator in this ratio, and our denominator will be whatever the pre-image length was. So pre-image, that is the original length that is dilated. And in general, your pre-image, whatever that length is, times K is equal to the length of the image. So you will take your pre-image length and multiply it by whatever that scale factor is to get the length in your new shape. Now, some important rules here. I guess let's just keep using purple. If K, and specifically talking about the absolute value of K, the scale factor is greater than 1, then your image will be enlarged. Meaning it's going to be bigger than the original. And if your absolute value of K is less than 1, then your image is going to be reduced. Made smaller. So, and again, just to reiterate what this absolute value symbol means, let's see, it was gray. The absolute value just means that we are looking at only positive values. All right, let's look at some examples using dilations and scale factors. So number 1, AB, segment AB is dilated by a scale factor to produce A prime B prime. So this copy, A prime B prime. If AB is 55 and A prime B prime is 35, identify the scale factor. And we really want to find the scale factor in simplest form. All right, so AB, that is our original. So this is considered our pre-image. And it equals 55. Now, this has been dilated by a scale factor to produce A prime B prime. So this is then our image, and it is 35 units. So please recall that scale factor formula, which involves taking your image and placing that over your pre-image. So whatever the length of your image is, divide that by the length of your pre-image. Take the new and divide it by the original. So our scale factor, K, is going to be, again, this image divided by pre-image. Our image is 35. That was its length, the new length. And then the original was 55. So what did I multiply 55 by to get to 35? And we want to express, this is a scale factor, but we want to write this in simplest form. So I can simplify this fraction by dividing both the numerator and denominator by the same quantity, which would be 5 in this case, would be the largest I could divide both by. So this tells me then that our scale factor is, well, 35 divided by 5 is 7, and 55 divided by 5 is 11. So our scale factor K is 7 over 11, which tells us here that we had some reduction, or what we call a contraction. Became smaller because K, the absolute value of K, I mean, it's positive anyways, but it is less than 1. All right, number 2 involves an image, so please either print it out or just recreate it in your notes. But to go along with this image, the rectangle on the right is a dilation of the rectangle on the left. Identify the scale factor in simplest form. All right, and the image has 2 rectangles, and we know the one on the right is a dilation of the one on the left. So this smaller shape is the image. It's been dilated from the pre-image here on the left. So if I want to identify the scale factor, I'm going to use the length of a side in my image, and I'm going to divide that by a corresponding or the corresponding length in the pre-image. So I want to make sure I'm using the corresponding sides. So notice here, the longer side 6, that is dilated to become 2. So our pre-image length was 6, the image length is 2. So in this, I will put 2 where image would be, and I'm going to divide that by the pre-image length, which is 6. I could also use the other 2 sides, right? I could use the fact that this side that's 5 is dilated to become 5/3, but I don't necessarily want to work with a fraction. Now 2 over 6, I can divide both of these by 2. So 2 over 6 is going to simplify to 1 over 3. So K is 1/3, and that does, make sense because I see that to go from the pre-image to the image, it became smaller. All right, number 3. This one also has an image. The figure on the right is a scaled copy of the left. Identify the scale factor. In this image, if you don't have a printer, just do your best to kind of hand sketch it. You don't need to recreate the grid, just maybe draw the shapes and then label the lengths that you can easily count. That's what I did in my notebook. All right, so the figure on the right is a scaled copy of the left. So that means this smaller shape, let's see, I'm going to write this out. Our pre-image is this smaller shape on the left, right? The original X, Y, W, Z. And that becomes the image, which is our scaled copy, and start with the same corresponding part. So I started our pre-image name with X, so I'm going to start our image name with I. So this would be shape I, K, H, J. So what would the scale factor be? And I could use any corresponding sides between the pre-image and the image, but I would rather use ones that I can easily count. And I could easily count WY and HK. So WY, that is 2 units, and that's in the pre-image. And then that corresponds to HK, which is 3. I also could use the sides XY and IK. XY is 1, 2, 3, 4 units long, and IK is 1, 2, 3, 4, 5, 6 units long. So whether I want to compare the purple corresponding sides or the blue, I'm going to use the purple because those are smaller numbers, so probably won't have to simplify it as much. So K is going to be found, the scale factor, by dividing a length in our image by the corresponding length in the pre-image. And I'm going to use the purple length, so I'm going to divide our image length, which was 3, by the pre-image length of 2. And that doesn't have to simplify. So our scale factor K is 3 over 2, which makes sense because this is an enlargement, right? This did get bigger. And K here, the absolute value of K, if you will, is greater than 1. All right, I want to do one more example together. Number 3. Oh, nope, that was number 3. Number 4. Triangle RST is dilated by a scale factor of 3 over 4 to form triangle R prime, S prime, T prime. Part A, if side ST is equal to 12, what is the measure of oops, forgot the word the S prime T prime. So that's the corresponding side in the dilated shape. If you want to draw a diagram, you sure could. So RST is our original, our pre-image. I don't really know much about it, but here will be R, S, and T. And right now, this problem has told me that ST is 12. Now this is dilated by a scale factor of 3/4. So this is K. K is 3/4, which means then that this is going to be a reduction or a contraction. So maybe R prime, S prime, T prime is kind of just a slightly smaller version of this triangle. So, oops, to just make a quick note, because the absolute value of K is less than 1, I know that this is going to shrink. All right, so we want to find ST, and please remember that to go from your pre-image to the image, you're going to take K and multiply it to your original. So multiply K times ST, and that will give us our length S prime T prime. So I'm going to multiply our scale factor of 3/4 times ST, which is 12. And when I do this, really, I'm just going to multiply the 3 times the 12 because it's like 12/1. So you're going to multiply 3 times 12 to get 36/4. And 36/4 is 9. So this tells me then the length of S prime T prime is 9. All right, part B to this problem and the last part. If R prime T prime is equal to 3, what is the measure of RT? So now we know R prime T prime, and this drawing I created here is clearly not to scale. R prime T prime is 3, and we want to find RT. Well, I know that whatever RT is, it's going to be multiplied by that scale factor, and that would then produce the length of R prime T prime. So our scale factor, that was 3/4, and that's going to be multiplied times whatever RT is. We don't know that yet, but we do know that R prime T prime is 3. So how do I solve this, right? This is RT is essentially something I don't know. It's a variable. I could treat it like X. And essentially what I can do here, this is a pretty neat trick. If I have 3/4 X equal to 3, I can simply multiply both sides of the equation by the reciprocal of this fraction. I want to undo the fraction, so I will multiply by the flipped version, because that will undo it. So you're going to end up multiplying both sides of this equation by 4/3. Multiply both sides by the reciprocal. That is what we did. All right, so I'm going to multiply both sides of this equation that I've set up over here by 4/3. So when I do that, the 4/3 and 3/4, essentially the 3's are going to cancel and the 4's are going to cancel, and we'll be left with just RT, which is what we wanted to find. And that is equal to, well, 3 times 4/3. When I see this, I notice a 3 in the top and in the bottom, so those just cancel and leave us with 4. Or I could see this as 3 times 4 is 12 divided by 3, which is still just 4. So RT is 4. Please let me know what questions you have on this lesson, and I look forward to seeing you in class.